Hello and welcome back to another festive coding session with Mr. Jacob, where we strive to implement in our Advent of Languages on each day of the 24 first days of December to implement the same thing in a different language. And what we actually want to implement is run or another kind of representation of this Christmas ASCII art tree. And we will do that today with the language SQL, or SQL. I'm not 100% sure how it's pronounced. I'm always being told it's SQL. However, everyone I know just says SQL. So yeah, I will try my best and may jump back and forth between the naming here. However, SQL actually is a database querying language. So essentially it is what you use in order to query structured data of your relational databases. And I have created a simple make file here, which should allow me to simply inside a Docker container use SQLite 3, which is the most simple kind of SQL parser and interpreter. It's actually a whole database, but we don't need the database part there. We only need the SQL part there that I could find to actually interpret our SQL data. So that's actually everything that I've set up, and we can now create our hello Xmas SQL file here and write a database query, and we will actually create one query that will output our Christmas tree. At least I hope that we will. And we will be using common table expressions for that. And common table expressions usually start with a with, and then you can define those expressions there, and then you can use them later on in a query. So let me show you what I mean by that, because SQL is actually not made to output ASCII stuff usually. So we are kind of tricking it into doing what we want. And what we can actually do here is we could do something like with tree, and now we create this common table expression here, which simply says, okay, no, I did not want some sort of strange autocompletion or snippet or anything, Vim, thank you. So what we could do is we could do something like select hello Xmas as text here, for example, as this common table expression, and then we could do something like select text, so kind of select the text column from this tree common table expression that I did there. And essentially now we kind of have selected the data out of our common table expression, our virtual table data that we just created there. Let me show you that this actually works. It tells us hello Xmas here down here. And now if I do something like, I could union this, for example, union all with another select here, for example, hello again as text. And if I now select those, actually our common table expression is two entries. So now we have hello Xmas and hello again. However, we are not 100% guaranteed that this will be ordered right. So what we might want to do here, because usually you don't have this kind of, we want to export or output something in the right order. We are usually applying some sort of filtering and actually ordering on that. So what we could do here, and what maybe should do, is something like as, I don't know, row number or something like that. We want actually 0 as row number, and then this one as text, and here we want 1 as row number, and this as text, and then we can actually select the text from the tree, and we can actually then order it by the row number, so that we are actually really sure that it is in the right order. So even though now I could maybe have changed the order of this data table here, it will still display it in the right order. So yeah, I guess that is the way that we are going to actually create this one. And yeah, let's think about that. Let's think about how we actually get this done by, first of all, taking our Christmas tree and quickly, and that is not the position that I wanted it to be. Actually, I wanted it to be up here, and now let's quickly comment that one out. So that we have something to reason about. First of all, I guess we need some sort of sequence iteration here in order to iterate over our number of groups. However, first of all, we need to somewhere define our number of groups. So let's maybe do that, and let's have something like params as here, and let's maybe do something like params with, what do we call that, num groups, for example, and we simply do a select and 3 here. So now we should have this this definition here with this specific column here, this num groups column. So now we can actually use that, and we have defined that somewhere. So this is actually the number of groups here. Now we need some way of iterating them. We need to kind of do something for the first, then the next, and then the third one. And we actually can only do that by using recursion, so in SQL or in SQL. So I will just tell it that we want common table expressions and we want them to be recursive. So we now should be able to do something as not only having our params here, but kind of defining something maybe like a sequence. And this sequence should be from 0 to whatever we want it to. So we give it an n. And so now we should be able to define something in this situation where we simply say, okay, we start at 0. We always start at 0. And then we union this. And you have to think of a little bit how actually a data query would now function, because we are now saying that we want to union this with a select of an n plus 1, so essentially the next iteration step there, where n is less than params.numGroups. So what we are essentially creating here now is this sequencing thing here should now be a common table expression which creates us a table with all the sequence entries from 0 to where we want it to be actually, where the maximum actually here is the number of groups. And we will see in a second if we will need to change that somehow. So that will be the maximum that we have in this sequencing table. So now I could actually change maybe this here. Let's quickly put that there, make this a comment, and let's see if we do something like select sequence or select n from sequence where n oh no, just let's select n from sequence, and this should actually already give us maybe the sequence if we did it right, and we did not. Okay, so where's our problem here? I did something quite wrong there. Yeah, I put a semicolon there, and I shouldn't have put a semicolon there. So let's see. Okay, now the next error is there. I guess I need to put a comma here, most likely, and then there as well. No such column n. Wait, what? Yeah, of course there is no such column n because I never recursively queried it. Yeah. Okay, so we never did tell him or tell the system, the SQLite, where we actually want to take this information from. So we need to select n plus 1, which makes perfect sense, but we need to tell it from where it should do that or from where it should get that. And we need that, of course, from our sequence expression here, and we want that recursively queried. So essentially it is now be able to query a certain n where we start at 0. And when it then does this and tries to union this, it will take a look at the n, which is 0, add 1 to it, and then we have this entry, and it will be taken from this recursive common table expression there. So that actually makes sense. However, I guess we need the params table as well because we are using it in a query, so we need to kind of create a cross product with params there as well to have this num groups ready to be queried here as a stopping point there. So let's now try again. And now, as you can see, we have from 0 to 3, which is actually not 100% right because we wanted to stop further. So it should be less than or equal. No, just a second. It should be less than params num groups minus 1. We need just to do one less there. And now we have our sequence actually that we can use to iterate something. And that's actually how you build recursively data tables in come on, in common table expressions in SQL. So now we have our sequence there, and we could actually start iterating them already here. However, what we first need is something that we have in our tree, all of those different spaces everywhere, and we need a way of creating all of those different spaces. So we need a way to kind of have the correct amount of spaces somewhere ready for us to be selected. And we can actually do that using more or less the same trick than we did this one. We can actually create a common table expression for us that has all the possible spaces strings in there that we can take then one out of where we actually need it. So let's see if we can't do that. And let's maybe call that spaces, and we need an n again, and we need now the string actually that we are building up there. So let's do that, and let's create that, and we essentially start the same way. We are having a 0 here first of all as n, and then we need the string. So we have a 0 and we need the string, and the string for 0 is an empty string. That kind of makes sense. And now we start again with a union all, and we do this recursively again. So we do select n plus 1. So we are going one further, and we are telling it that it is essentially then the string that we have in this part of the building iteration, and we concatenate that with simply another space there. And now we need to tell it from where we actually want to select that. And we want to select that again from our spaces, of course, and we will need the params again, and you will see just in a second why. Because now we will need to be able to limit that somehow. We are kind of creating now a virtual kind of table within our query with a common table expression, and we are actually creating a list of all possible spaces that we need. So we need to know what is the maximum amount of spaces that we need. And the maximum amount of spaces that we need is actually this spaces amount here, within the last group here. And that is actually defined by the number of groups that we have times 2. So this will be actually the maximum number of spaces that we need. So we can do where n is less than or actually equals. I'm not 100% sure. Let's maybe ensure that we have enough. We will see in a second. So where n is actually less than params.numGroups times 2. So essentially this should create our spaces for us. So if I do now something like select maybe the string, or let's maybe select the n and the string from spaces, it should actually create a couple of lines for us. So let's see, it does not, because I did something wrong there again. Syntax error near line 10, error here. So let's see, what did I do wrong there? I did something wrong near the tree. Okay, I did miss a comma there, I guess. No, I wanted to do please a make. And now you can see that it created this thingies here. And if I would now check, I would be kind of sure that the second column here is the spaces that we just wanted to be created. Okay, so this works out as we wanted as well. So now we can go ahead and maybe create our tree a little bit better here. So let me remove this hello tree stuff here, and let me remove our debug stuff here, and let's just get this in there again, so that we are now from our tree common table expression are actually selecting what we want there. So what we now need here is we need a couple of entries which start with a row number and or with two columns, with a row number and a text, and the text should be the combination of what we actually want there. So how can we actually do this? Yeah, we do it like we always do here. We start by selecting something, and we are actually selecting something like, first of all, the row number. And the row number is, of course, the n that we are currently iterating, and we will see in a second how we are actually then iterating, times 2. Because essentially per group, we are always printing 2 lines. So we need to incorporate that into our calculations here, don't we? So our first line will be the currently iterated row number times 2. And how do we actually know? And we want this as row. Did I call it row number? I think I called it row number. So we have already this now as a row number there. That is actually the first part of our first line of the select. Now we need something, for example here, something, don't matters as text. And that is actually, how do we do that? Let's first see that we can actually iterate, and we iterate by simply doing a from. We get our sequence here. We already have that, so that we actually have this n here, so it is executed for each of our sequence entries, and most likely we will need our params again. So let's actually select from them again. So now as we have this as a row number, we need this text. And there is actually the possibility to call within SQL a printf. We actually have a printf function in SQL, at least in SQLite we have that. I'm not 100% sure if that's actually defined as part of the SQL standard, but it works here, and it works in mostly any database that I know. So we can actually easily use that to kind of incorporate now our different parts of our text that we need. So let's maybe split this up here, and let's do, okay, we need some sort of string there, and then we have our slash, and then we need another part of the string there, and then we need our backslash there. And that should already do that. And now we need the spacing in front of and in between those entries. And we can actually get those by selecting the correct line of our spaces common table expression there. So what we actually do now is we simply get the str from spaces where the n within this table expression equals the correct amount of spaces that we know that we want, because we created every possibility here where we did that recursively. So essentially what we want now is we want to know how many spaces in front of that we need, and that is actually params.numGroups minus the current number of iterations that we are in. That is what we need in front of there. And the one that we need in the middle is more or less the same. However, there we need the current number of iterations times 2. And this would be our first line of the text. So we can now actually, let's maybe try and execute that. And we should already, if I did not create an error here, and I created, of course. So where did I do that error? I have done something wrong here. What did I do wrong there? Yeah, I guess I cannot do it like that. I think I need to kind of put that in braces, because that will be a result set. And yeah, okay, still not working as it should. Maybe that comma there is the problem. Yeah, that comma there was the problem. And yeah, I'm not 100% sure why we don't have spaces now. We should have seen this thing in a way that I just thought we would have. So it seems to me maybe we didn't create our spaces right. Okay, so where n equals, maybe we need to specify that this is actually the n that we get from the sequence here. However, I'm not 100% sure that this is needed. Okay, so we were simply using the wrong n here, I guess, because we were internally here using an n as well, and it couldn't differentiate between the one that we were using and the one that actually was taken from the sequence here, so that we actually were selecting the right thing there. Okay, that kind of makes sense. So now, as you have seen, we now can create the first row of our tree, and I guess we can now easily create the second one as well by simply taking this whole select thingy here, doing a union all again, to union it with another result or another result set, put this select there as well, again, do a n times 2 plus 1 now as row number, because we want to advance one further. We have always 2 in one of those groups, as I've said before. And now we are essentially doing simply the same here, but correcting this by moving one further to the left with our initial spaces. And here we will just do a plus 1 here before multiplying this with 2, because we need to have the spaces in the second line here that are equal to the ones in the next iteration already. So now we should actually already have this kind of zigzag shaped tree. And as you can see, we have. So now what we need is another union all, of course. And now we need to kind of repeat our divider line there. So essentially this one here, and we need this a couple of, or a specific amount of time there. So we are simply doing that recursively again. And in order to have that ready, we actually need something like we did for our spaces, but we need it with our minus characters, don't we? Because we have that in a dynamic way. That might not be the so let's call this divider, not be the perfect way to actually do that. But yeah, I think everything that we're currently doing here isn't perfect, because usually you wouldn't do it like that. So essentially now we have a recursive divider table as well, where we only want to use one entry. However, what we need to do is we need to definitely make this a little bit bigger than the spaces, because what we need is we need this to be the maximum number where we need our divider, which is this one. And therefore now we should be able to actually select that here and select str from divider, where n equals params dot num groups minus times, wait a second, times 2 plus 2. That is actually what kind of divider line that we want. So let's quickly check that this actually prints our divider. It does, of course, not, because which line did I make the error? Rust brain? Wait a second. No, that was something very different that we had before. Okay, so let's see. M divider params number from error here. So it just doesn't like the, I think I most likely have not created some sort of brackets there at some position. So essentially we are, no, wait a second. I needed to do it like that. I just had it at the wrong position. And of course, this one is already complete. It has its from. I just did not capitalize it, and therefore I couldn't see that it was there. So maybe we should structure it the same way. And now we should have actually not a divider line. What did I do wrong there? Yeah, I needed to, of course, create the cross product here with the params as well to be able to access that. And then it will simply not work, because parse near selects to the left and right of, yeah, we need of course to give this, first of all we want str as text, and we need this a row as well. So what we need is something like the row count or row number. How did I call that? Order row number. So we need a row number here. And we did n times 2 and n times 2 plus 1 here. So essentially what we now want here is n times 2 plus 2, I guess, most likely as row number. We will see in a second. So let's see. Yeah, now we have our divider line there, because we needed another row number there. And now what we need is we need our trunk there, don't we? And our trunk is mostly the same as this one that we already did here, with spaces in front of that. So the trunk is here, the spaces amount that we need, and then two pipe characters there. So we can actually kind of take that from our creation of the tree pattern there as well. So we do another union all here, and we simply put that there, and we can actually do and put in there the row number plus 3 now, because we want to be the next section here, and we want spaces with actually 2 pipes at the end, and we take the spaces here. We only need 1 pair of spaces, and this is actually, the spaces is exactly the number of groups that we need there. So we need the number of group spaces in front of that trunk, and we kind of need that 2 times. So let's copy that, and I think I just kind of wait a second, did something and removed something here that should have been there. And yeah, exactly, and this should be here. So now we can actually copy that and copy that again and do a union again from this one, where we now print a second one there, and we give this n times 2 plus 4 here as the row number. And let's now actually execute that, and I have done something wrong there again. So where did I actually did something wrong? Okay, so parse error, syntax error, spaces where n params num groups text. Okay, so spaces where n params num group. This should be this one then, I guess. So or this one, or did I just destroy one of those here? No, the divider will still work, I guess. Let me quickly comment. Those lines out here to see if we have something in this section. Okay, we did something wrong in this section. So let's see. Let's only comment in one of those, and I guess I need to remove 1 further character there. So let's see. Okay, so this is already a problem. So what we are doing here is now we are selecting n times 2 plus 3 as row number. This should not be a problem. Then we are using printf actually to print out this this character sequence here, and as a spaces there, we are selecting str from spaces where n equals params num groups as text, and we take all of that information from the sequence and from params. So where's the problem there actually? This should work. So again, where is the error? I think it's something very obvious that I'm not seeing. I think you are already all screaming at your screen that I'm doing something wrong there. So as text, so doesn't it like that comma there? I think it doesn't like, yeah. Okay, I think it doesn't like that comma there. However, wait a second. I don't want to do this actually based on sequence. I only want to do this on params, because otherwise it would repeat it over and over, and then I can't use that n anymore. Okay, wait a second. So actually we can't use the n here anymore because we are not using the sequence common table expression that we actually created, because we don't want to iterate that. But we need the maximum number there. So what we actually need is we need something like select num groups from params, and we want num groups plus 3 actually, maybe, and we want that as row number. Yeah, I hope that actually works. So then here we want something like, and let me quickly just remove this out commenting of that all. So we want 1 less there, we want one less there, we want that to be indented quickly, we want that, let's just remove all of that, and let's copy that once we have that working. So essentially this should now get us the last group number there, and we need to of course multiply that by 2, because that is the last. We have always 2 lines in our tree segments there, and then we want to print that, and we don't want that union all at the end. So let's see. Okay, so now we have that. However, we kind of did something wrong here, and I think I did the same thing here with our divider line, and there you can actually see that we have a problem in this sorting if we don't have the proper row numbers there. So what we can actually do is we can kind of steal that. We can put that there because that should actually work out as well. And we just give it +2 here. And essentially we only need +1 and then we need +2 here because num groups times 2 should be the last of our base rows there, I guess. So let's quickly see that this now works. Okay, this now works. So now what we can do is we can do another union all and copy another one of those trunk parts down below there. And we are finished. We have our Christmas tree written in plain SQL. And I can actually now change this here and make it kind of like, for example, I want a tree of 6 here. And if I now execute that, I get my Christmas tree of 6. And we have done that in SQL. And I still can't believe that we actually did that and created our ASCII art Christmas tree in plain SQL. So as you can see, there is no database behind it. We are only using common table expressions here to create all sorts of intermediate data structures there that we can actually then use to query the data. So you can see that we can do a lot of crazy stuff with SQL, and of course usually this is done and needed to query complex sorts of data somewhere, like for example to query tree structures within databases and all that sort of stuff. But you can misuse it a little to create a little festivity there by simply making a Christmas tree appear out of nowhere in your SQL. So you could essentially paste this SQL code into any SQL database, at least most of all of the SQL databases which understand all of the functions that we use, like printf, for example, and it will give you this Christmas tree. And you could do this, please don't do this on your production database. However, I hope you had fun in this next installment of our Advent of Languages, and you will be there tomorrow when we do it in another language all over again. So yeah, I hope to see you then. Bye!